All right, Chapter 1, Lesson 6, Solving Compound and Absolute Value Inequalities. So today we're just going to take a look at Day 1 compound inequalities. Well, what's a compound inequality? Compound's just talking about two. Okay, so like compound words, basketball, basket, and ball. Two words put together to make one. So here we have two inequalities joined by the words and or. Okay, um, so and inequalities. Both inequalities must be true. So when I look at this sentence, I want to be a millionaire and not work. That's talking about both parts. Want to be a millionaire and don't want to work. So you can see and is written here. Sometimes that variable is inside, and I have two separate inequality symbols there, and they're combined together to make one. So how do we solve these? So if I have this compound inequalities and inequality, again, I kind of just draw these lines down just to kind of see my middle, and whatever I do in the middle, I do to both outsides. So I'm just looking at the middle. What do I need to get rid of first? I'm solving them the same way we did before. This time I'm going to subtract 8. So minus 8, minus 8. Again, whatever is on the inside, I do the same thing to the outside. So negative 12 minus 8 gives me a negative 20. 4x comes down, 8's cancel, 32 minus 8, 24. And divide by 4. Same rules apply. If I multiply or divide by a negative, I need to flip. Okay, so here it's a positive 4. So negative 20 divided by 4 is negative 5. 1 and 24 divided by 4 gives me 6. Signs stay the same. So our answer is negative 5 less than x less than 6. Let's take a look at our graph now. So same idea, this time we're just going to have two marks on there. One at negative 5, the least value, greatest value is 6. Circles are the same idea. So here x is greater than, or negative 5 is less than x, so it's open circle. X is less than 6, open circle. And if I'm looking at this first part here, negative 5 is less than x, I'm shading to the right. If I'm looking at the other part, x is less than 6, I'm shading to the left. And wherever these graphs overlap, that's where we're going to shade. So when I'm looking at my shading here, I have this shading in between the two circles. Okay. Most of the and inequalities are going to be shaded in the middle. So let's take a look at part B. Again, with these I do like to separate it just because there's three parts. If you don't want, still don't have to, okay? So get rid of that minus 2 by adding 2 to both all three parts. So I have 12, 3y, 2's cancel, 19 plus 2, 1. Dividing everything then by 3. So 4. 3 divided by 3 is 1y. 21 divided by 3, 7. Good, didn't divide by a negative, so just bring our signs down. Sketching our graph. Got my two marks, 4 and 7. Again, y is greater than or equal to 4. So this time I have a solid circle at 4 shading to the right. Y is less than or equal to 7. Solid circle here at 7, shading less than to the left. Overlap's going to be here in that middle. Okay, so that's the and inequalities. Both parts have to be true. Where both parts are true, that's going to be our solution. What about our or inequalities? Okay, so if I gave you the option of going to the movies or out to dinner, you can pick one. You don't get to do both, one or the other. So in this problem, one has to be, either one could be correct. So as long as one of them is correct, the inequality is true. Okay, so here I'm given two separate equations always with the or inequalities. Okay, we have to solve them separately. Most of the time they're different equations even. So you can see here in A I have x plus 3 less than negative 1 or negative x greater than or equal to negative 4. So let's solve this just like we would a normal inequality. We're going to subtract 3. So x less than negative 4. Or I can solve the other side here. Negative x greater than or equal to negative 4. We're going to divide here by negative 1. Leaves me with an x. The 4 now becomes positive, and when I divide it by a negative 1, I need to flip that inequality so x is less than or equal to 4. Now, let's take a look at this graph. So, same idea. I got a negative 4 and I have a positive 4. Looking here at the left side, x is less than negative 4. Open circle would shade left to the left side. And then I also have x is less than or equal to negative 4. So here's going to be a solid circle. X is less than, so it's shading to the left. And it actually overlaps that. And again, either one could be true to make this inequality. So anything less than 4 is true. So this whole thing would get shaded. This other side doesn't even really matter because any number less than negative 4 is going to be less than or equal to 4. So my graph is just shaded all to the left of 4. Typically that's not a normal graph, okay? We'll take a look here at letter B, and then we'll show that graph here in letter B here in a minute. So my first equation here, m minus 7 greater than negative 12. To get m by itself, we're going to add 7. So m, 7's cancel, greater than negative 5. Or take a look at our other side here. We're going to subtract 2 from both sides. So negative 3m greater than positive 36. Dividing then by negative 3. So negatives cancel. M, since we divided by a negative, flip that inequality. 36 divided by 3 gives me a negative 12. So let's take a look at our graph. So I have negative 12 is on the left, negative 5 is on the right. Make sure that they're in the right spots, even though the right side is negative 12. When I graphed or solved it, 12 is smaller, so it needs to be on the left side. Okay, that is the one thing we'll be picky on when you're doing these graphs. The order has to be right. Okay, so m is less than negative 12, so open circle at 12. Less than is shaded to the right. M greater than negative 5. Open circle at negative 5. Greater than is right. So here is your more traditional graph of an or inequality. So you have the dots, and they're kind of shaded away from each other for the most of the time. So we do have some special cases here. Take a look at real quick. We have no solutions, or we have many solutions, or infinite solutions, all real numbers, things like that we can talk about. Um, so let's solve this first letter A and see what we get. So here we have an and inequality, so again, both have to be true. So we're going to solve, and we have two separate equations. So left equation here, we'll subtract 2, 13x less than equal to negative 26, dividing them by positive 13, x less than equal to negative 2. So that's my left side. My right equation then here, we're going to add 10, 2x greater than equal to 21, divide that by 2, x greater than equal to, we can put 10.5 or 21 over 5. Now remember, this is an and. So both of these have to be true for this inequality to be true. So here I have a negative 2 and a 10.5. So x is less than or equal to 10.2. So if I'm looking at that, that's a solid circle. Less than would be shading to the left. And then I have x is greater than or equal to, so that's another solid circle, greater than shading to the right. Now, remember, and is overlap. Both have to be true. Do I have any overlap? No. Since there's no overlap, this answer is a no solution. Both have to be true. And since neither one overlaps each other, my solutions, there's no values that are congruent. So that's your no solution. So B is probably going to be our many solutions. Let's take a look at it. So again, we have two different equations. Now it's an or inequality, so again, only one has to be true or the other. So let's solve. We're going to subtract 5 on both sides here of this first equation for inequality. 5's cancel, x greater than negative 7. Dividing here by 7 on the second equation, so x is less than 11. Again, this is an or statement. So when I look at this graph, when I'm shading, I have a negative 7 and I have an 11. So the negative 7x is greater than, so it's open circle shading to the right, greater than. The second is x is less than 11, so open circle shading to the left. Now, again, this is an or statement. So 1, so 7, anything bigger than negative 7, or anything smaller than 11. So when you look at that graph, that's going to include every single number that we have. Okay, so this is our many solutions. Infinite solutions, or infinitely many. Okay, sometimes we'll say all real numbers, so that will be the all real numbers sign. Okay, so those are my many solution wording here. Many solutions, infinitely many solutions. Again, there's an infinite number of solutions there. I can pick any number. As long as it's a real number, it's going to be on that number line, and it will make that inequality true. Okay. So that concludes our day one notes for absolute value of inequalities. We'll take a look at more inequalities and take a look at the absolute value part tomorrow.